Okay, Elliot, we're recording, so go ahead whenever you're ready.
Okay, so this is Git Essential. So my goal here is to give you a basic grounding in Git, and then Chris and Robert will talk about more specific workflows, how to use Git in the context of the TC work that we're doing. All right, so just to start off some basics, rather, this is what we're going to cover. Git is about managing commits, not files, and I'll explain what that means in a bit. And we also have the concepts of local repositories and remote repositories. Git uses a two-phase commit mechanism, which is probably not going to be what you're expecting if you're used to systems like Subversion. And then in Git, we have these concepts of pushing and pulling that are very important. All right, so the first thing is to not panic. So Git makes it really hard to lose work. You have to go to pretty extreme efforts to get things so mangled in your repository that you can't recover it. And another thing about Git is that a Git repository is just a directory structure on your machine. So if you're ever worried about, you're going to do something and just totally hose up your repository, simplest thing to do is just make a copy of it, just copy the entire directory, and then you can always get back to it. I like to say that a little discipline goes a long way. So just doing things in a consistent way and in a thoughtful way will avoid a lot of problems. And then I certainly like SourceTree. It's one of the free Git user interfaces. I know Chris uses SourceTree as well. There are other Git user interfaces you can out there. There's Tortoise Git that integrates with the Windows Explorer, some other tools as well. SourceTree is the one that I think most of us use. And then finally, of course, there's no substitute for communication among the team members. So it's not really a problem that we have within the TC. We're pretty good at communicating. But when I'm talking about Git with other development teams, sometimes that's sort of a new thing. All right, so Git repositories.
Elliot, can I just interrupt and say, you also can use SourceTree if you just want a really easy GUI interface.
Yes.
It is not a requirement for doing complicated stuff. It can just be, if you prefer to use a GUI, it can be easier.
That's right. Yeah, and in fact, I'm a command line guy, and I'm finding myself using SourceTree more and more, even just for really, basic operations like just simple, pulls or pushes or whatever. So that's a good point. It's good to know the command line. I think the basic command line stuff, but there's more complicated things for which a tool like SourceTree is really the only way to do it, just because it's complicated stuff. All right, oops, didn't mean to do that. So a Git repository. So a Git repository is a collection of files, of course, but it's really the changes to those files over time. And one of the things that distinguishes Git from systems like Subversion is that the entire history of the repository is maintained locally as part of your repository metadata. So for example, if you clone any one of our repositories from GitHub, your local copy is a complete copy, meaning that it has all of the history of all the files from that repository. And so that's an interesting aspect of it, but it means that you can, when you clone a Git repository, when you make a copy of it, you have everything, and so you don't need to be connected to the internet, for example, just to look back in time where you do a Subversion. There's very little magic in a Git repository, in the sense that there's no, other than just the .git directory itself, which is where all the Git metadata is stored. There's no magic files. There's no special, file that's really a file system under the covers or anything like that. It's just, everything is just basically just files on your file system. And one of the things that means is that you can copy, move, and share Git repositories just as you would any other files. And you don't have to worry about, something getting out of sync or suddenly the metadata is not right because you'd expect it to be in a particular directory or something. So for example, if you have a Git repository on your local system, you can just zip up that directory, send it to somebody, they unzip it. Now they have effectively a clone of that repository. So there's no magic there. And really, as long as you don't delete that .git directory, you almost can't lose data. All right, another important concept with Git is that Git manages commits, not files. If you think about the way Subversion works, for example, you're really committing individual files, and the history is maintained on a per file basis. With Git, you're managing sets of commits, where a commit is the set of changes made to one or more files, and they're committed at the same time. So that's what we would call an atomic action applied to multiple files. And each commit has a unique identifier that reflects the changes that were made in that commit, the actual bytes of the files that were committed on that commit. And one of the things that means is that the same commit, that is the same set of changes made to a given set of files, can be in multiple repositories, and they will have exactly the same commit ID. And that's the mechanism by which you can have distributed Git repositories and yet reliably sync them up. But what it means is that, for example, there's no notion of version numbers in Git. You just have a sequence of commits. Commits have these long, hex identifiers, and that's the way that we think about them, at least at the base level. You can do things like tags to associate, something that looks like a version number to you with commits. But fundamentally, a commit is just a set of changes that were committed at a particular point in time. It has a unique identifier that's globally unique, and that's all there is to it. And then, of course, a time sequence of commits represents the history over that set of files. And then finally, Git compares files by content, not by name or directory. And so what that means is that if you have two files with different names but exactly the same bytes, Git will consider them to be the same file with just different names for the same file. It also means that you can move and rename files, and Git tracks those as changes to the object that is that unchanging set of bytes. Whereas, like, if you think of like Subversion is actually managing the directories directly. So if you move things around, it gets weird. So with Git, you can move, you can rename things. It's a very low cost operation, and the repository will still recognize that all you did was change the name of a file because the bytes are the same.
Elliot, can I ask a question about this slide before you go on?
Sure.
I get the impression here, and I just want to confirm that I'm right, that a commit also has a set of metadata about itself. So obviously there's a timestamp in order to put together a time sequence of commits, and there also is a unique identifier. You said there's tags that you can put to a commit, which are essentially your own version IDs. So am I right that all this is essentially metadata about a commit? And is there any other metadata about commits that is interesting and important?
I don't think so.
Well, there's a little bit.
A little bit? Okay.
The main piece of metadata that folks on this call would care about with a commit generally has a message associated with it. So when you commit something, whether it's one file or 20 files, this is the change I'm making. And so when you look up the commit, you see that hex value, which is obviously meaningless to a normal human, but you also see that message that says what changed. And so something Chris and I will talk about later is that you want to have good hygiene on your commit messages, because otherwise, in the rare case where someone tries to go back and a bunch of garbage text. But if you have good messages, you can actually see, oh, this is what changed, and this is what changed, and this is what changed. So the main metadata that we care about in terms of normal is really the message. There is other metadata that the machines care about, like that timestamp.
Yes,
So,
yes, good point.
One thing I might add based on what Tom said there, you don't associate tags like when you're committing something. That's not when you associate a tag like a release version number. Tags are really a totally independent thing, and trying to think about them together with commits can cause confusions. Can cause multiple confusions. Yes. Tags are kind of a separate concept that whenever you're ready to release something, you say, here's a tag, and it's just a shortcut of saying, at this point in time, this is where things stood. So, software is often going to have tags for their release because it takes you directly to that commit, the final thing that went into this release.
Yeah, I had that sense from
but
what Elliot said.
If you're, just going to be a DITA TC contributor working in one of our repositories, you're not going to have to think in terms of tags at all.
Yeah, you certainly won't be creating them as a casual contributor. Tags are something that are only really created at release boundaries by administrators of a repository.
That's right. Okay. Does that answer your questions for now, Tom?
Yep, absolutely. Thanks.
Okay. So to continue this discussion of commits, so a branch is just a set of commits. Right, so we get repositories are organized into one or more branches, and a branch is just a sequence of pointers to commits. And then the newest commit on the branch is quote the head commit. So there's, on any branch, there's always the last commit that was made to it. That's always the head. And when you create a new branch, you're just creating a pointer to a specific commit, and then giving that a name, and that's the name of your branch. All right. And Robert and I were, and Chris and I were discussing this. I think it's important to understand that branches are just pointers to commits. The commit is the primary thing. The branch is just a way of really imposing some organization onto your commits. Now, one of the implications here is that because branches are just pointers to commits, branches are very lightweight, meaning that they're quick and easy to create, change, delete, and so forth. And if you compare that with Subversion, where in Subversion, branches are actually reflected by creating completely new directory structures, which can take glacial time to create, depending on the nature of your repository. With Git, you can create a new branch in a matter of milliseconds and immediately start using it. And so one of the implications there is that you tend to use branches a lot more for organizing your work. And Chris and Robert will talk about that in more detail when we get into the workflow aspect.
Yeah,
by convention,
I can actually show creating that, which might help get it stuck in people's heads, hopefully. So that'll be later.
Yeah. All right. Then by convention, you usually have a branch named the master, and then you have other branches, but the branch names are completely arbitrary. But there are some conventions like master and develop and so forth. All right. So local and remote repositories. So Git repositories are distributed in the sense that there's no central repository in the way that there is, for example, for Subversion. Right. So for systems like Subversion and Perforce, you have a master server that maintains the history of everything and allows collaboration, and then you have local checked out version copies of those. Right. With Git says no, we just have repositories, and sometimes they're connected to each other and sometimes they're not. And that allows the version history to be distributed, but yet still coordinated because of the fact that a commit is is a thing that has identity based on the things that were actually committed, right? And that's what allows you to coordinate two repositories to each other, see that they, they have the same sets of commits or they don't. There's no requirement that a Git repository be associated with any other Git repository. So, for example, you could just make any directory you want on your machine into a Git repository, just so you can manage your own local work and never share it with anybody, right? Or you can, of course, use it for collaboration the way we are with the TC work. So a Git repository that's on your machine, that's a directory on your machine, is a local repository, right? Meaning it's local to you and your work environment. A repository that you relate your local repository to is then a remote repository. Typically, those remote repositories are going to be on, some different machine, on GitHub somewhere or some server that somebody's maintaining, but they don't have to be on a separate machine. You could, in fact, relate two repositories together that are just directories on your machine, and you would still have this local and remote relationship.
I'll say if all your I'll wait until you're done with the slide. Sorry, before you move on, I'll add something.
Sure. And I'm just going to say there's no built-in notion of a single master shared repository, right? But even though that notion is not built in, that's in fact how we typically use systems like GitHub, right? Is we've established for our own workflow purposes that we're going to treat the GitHub repository as the main master repository, but that's not inherent in the way Git works. Just to make that clear. All right, go ahead, Robert.
Yeah. An important conceptual aspect of Git, in terms of how we're going to be using it, if you are casually contributing to the spec, you probably don't need to remember most of this, because we do just fall into that last piece where, with the way we're using it, the master repository is up at GitHub. I think helpful aspect of this is that because it is distributed and it's built in a way that you can all have your own copies everywhere, that does mean that, unlike with SVN, you don't have to constantly be connected and pinging the server to do things. But yeah, at least in terms of how we use it for TC work, it's going to be that last one where we're using GitHub as the shared repository.
Right.
So we can all think of GitHub as our master.
Yes. Now, one of the ways that this allows the way that you use Git to be different from the way you would use Subversion, for example, is exactly for the reason that Robert just said. Because you don't have to be connected, you can make changes and do your own work locally, commit those changes to your local repository. Those changes are now saved for your own purposes. And then only at some later point in time, push all those changes up to some shared repository. And so that allows you to, at least the way I think of it is, it allows you to protect yourself from your own mistake making, just because you can make frequent local changes and it doesn't affect anybody who you might be collaborating with until such time as you make those changes available to them later.
Another question. Suppose that you are doing lots of local work and lots of local commits, and then at some point you decide that some of these local commits are important changes or necessary changes that you want to merge in. I don't want to step on terminologies here, but changes that you want to add to the main repository on GitHub. Is it usually easy to sort of find the changes that you want to add to the main repository and sort of select them and say, I only want to put these ones into the main master?
I'm not going to claim that it's easy, but
I'm going to say this is where good hygiene and working practices come into play. And Robert and I can talk a little bit of, you know, sort of what we think are good habits to get into. But you can, you know, get into trouble if you go down the road and you make a huge amount of changes, you know, to your local stuff, and you send a pull request to a Git repository saying, hey, I want to contribute this. It will become impossible for the master repository to accept. And
I think
Robert,
I think maybe the straightforward answer is, Elliot was talking about branches, and what we need to highlight coming up is that you can have as many branches as you want, and as long as your branch has focused work on it, it's a really easy way to collect related changes and at any point send those in as a suggested change. If you have one branch and you make 500 things in there, it's a lot harder to go back and pick out the 10 that you decide were worthwhile. So work on independent things on different branches. You can do as many as you want at the same time, as long as you practice good hygiene, and then you can easily commit them later or share them later.
That also
we can share that.
Like, we're beginning to sound like public health officers.
And this is Alan. Is this the good time to ask about renaming files, or
Sure.
will that come later?
Yeah, so the short answer is that renaming is not a problem as far as Git's concerned, because renames and moving of files around in directories is itself a track change, right? Because so remember that I said that the Git tracks the files based on the actual bytes in the file. So if you have file A that you've committed and you rename it to file B, when you commit that change, Git says, oh, here's the same sequence of bytes that I used to know as file A. Now I know it as file B. I will record that change in the history, but no change was made to the actual bytes themselves. But the name change is recorded.
Okay, that's great. That's so a light bulb's gone off in my head. I do struggle in things like SVN over renaming files and maintaining the history across file name changes, but that's just not an issue here.
Not an issue at all. You know, obviously, you don't want, it could confuse somebody for reasons having nothing to do with Git, but yeah, as far as Git's concerned, name changes and moving of files around in directories is completely tracked as part of the change history, which is not the case in Subversion.
Awesome. Yeah, I love the analogy. You're managing commits, not files. So
that's right.
That's very helpful. Yeah.
Yeah, and that's why I started with that. All right, so I have some actual pictures here. So to talk a little bit more about local and remote repositories. So we have a managed repository on our GitHub server, and then I'm going to clone that. So the action we talk about is cloning, and when I clone that, I'm going to create a complete copy of that repository on my local machine. And so I'm going to create a local Git repository that at the time I do the clone is identical to the remote one in terms of it has exactly the same sets of commits, the same history, everything is the same. Right. So then by convention, we call the remote that we clone from the origin. And that's just a conventional name, but it's used almost universally. And then
I have a question.
Go ahead.
Elliot, this is Maria, and I have a question. So do you have to clone the entire GitHub repository, or can you just clone part of it?
I know it is possible to clone a subset, but usually there's no point because of the way Git manages files, it doesn't really cost you anything. There's no real savings in trying to only clone part of it, unless the repository was had been created and it was just monstrous. But usually people don't.
It's tricky, and for our purpose, there's no reason to do it.
And Maria, our repositories for the TC are all small enough in size. So it's not like it's a problem for, spacing your hard drive. We don't have a whole lot of big images. It's XML files. You know, it's pretty fast and pretty instantaneous to clone any of our repositories in complete entirety. It's not like what you would happen if you were like cloning the content of a entire CCMS with a lot of image files.
Okay, thanks.
That's right. Yeah, and just to mention, part of the original design goal with Git when it was created was because it was going to be distributed and distributed to people all over the world. It's highly efficient in how it uses storage and highly efficient in how it uses network resources. So, for example, when it compares your local repository to some remote, it's doing that by comparing MD5 hashes rather than actually doing a byte comparison of the files, which is what Subversion does. So, like Git is almost instantaneous to determine that files are different, whereas Subversion is, you know, as slow as it could possibly be.
Yeah.
Right, so we have
one thing that
go ahead.
One thing that I clarified for some of my colleagues when I tried to explain something similar a while back, said that it downloads the entire repository and the history of every commit, every file, every change. I mean, that is all stored in that highly efficient way with MD5 values. What I heard initially was that, you know, it downloads the entire repository with all the history, which means if a file has changed 50 times, my hard drive must have 50 copies of that file. And that's at all means. Your hard drive will have one copy of that file and then a whole bunch of hashed up pointers that can get you to the file at any other point. But it's very efficient, very small. You don't have every copy of every file that's been in there.
That's right. All right, so having cloned from some remote repository, now if somebody commits changes to that remote repository in the future, then you do what's called a pull, and you pull the commits from that remote repository into your local repository to update your history. And so that's the basic mechanism by keeping two repositories in sync, is you pull from the remote. Likewise, when you make changes and you want to send them to the remote repository, you do what's called a push. So you push your commits to the remote repository. And then by pulling and pushing, you can keep two repositories in sync so that they reflect the same set of commits. So to get back to Tom's question about, you know, like, I made a bunch of changes and what do I do? So you make a bunch of changes locally. Maybe you've made 10 commits on a branch. You can then choose to push some or all of those commits up to the GitHub, up to your remote repository. There's also an operation called squashing commits. So you can take a set of commits and you can squash them down into one commit, so that instead of sending your minute by minute change history up to all your colleagues, you can just send the result of what ultimately came out of all those changes. That's a little more involved, but you see that quite often. And when people make pull requests to open source projects, for example, they're always asked to squash their commits so that they're just sending one commit instead of 100. But Git makes that possible. And some systems, and I think now GitHub, they do it automatically, can automatically squash commits. Do you know anything about that, Robert?
Yeah, I don't think we need to worry about that here.
So a commit is
it's probably.
A commit is somewhat analogous to doing a save, but surely it's not true that you're actually doing a commit every time you save your file from your editor when you're working on it, right? A commit is something that you do after you've, it's not like it's not like what you have to do every minute when you're working. It's just you're just using that. Yeah.
Right. I mean, like the way I typically work is, I'm working on something for some amount of time. I get something to work. My unit test passes for the new method that I just created, or, I update a topic and I'm happy with what it looks like. I'm going to commit at that point so that I save that progress and then I go on, right? And I do that fairly frequently rather than like working all day and then committing my changes at the end of the day. And that's as much just to make sure that I don't lose, I don't mess myself up by breaking something that had earlier, worked, right? But if I'm collaborating with other people, they probably don't want to see that entire change history.
Yeah, I just wanted to reassure myself that by asking that question, I just wanted to reassure myself that squashing was not likely something that I was going to have to use.
Well, probably not.
I want to
certainly
just
not in the
jump
context of
in.
what we're doing here.
I want to just jump in and say I think Elliot is doing a fabulous kind of overview, but it may be, kind of overkill or over the head for some, not everybody on the call. And, we can do, we're going to do more concrete hands-on demo in the fall. We've put together some kind of simplified cheat sheets that can be more, where you really don't have to think about all these things. You just know these are the practices you follow. So if you're feeling overwhelmed at this point in time, don't worry. If you think this is, a great level of introduction to Git, and it's great for me, we will make this all work. And Elliot, I think this is great content, and Tom and Alan and other people, super questions. Maria, too.
All right, okay. Thank you. So a couple more important things about remote repositories. So you can have any number of remote repositories associated with your local repository, and where that becomes important is when, for example, you're contributing to an open source project where you don't have commit rights. And so typically what you do is you create what's called a fork of the repository you don't have commit rights to, and you do that like on GitHub. Right, so now on GitHub, you've got your own copy of that open source project, and then you clone your fork locally. But that means there's now two different repositories, the original open source one and your fork of it, that you need to relate your local.
And I just want to jump in and say, this is, how it's going to work for most contributors to do the TC repositories.
Right.
You're not going to have commit rights. So what you will do is you will fork, the main TC repository or the TechCom TC repository or the learning and training or lightweight DITA repository. And, that will be your, origin if you want. And then the upstream will be the actual TC repository.
Another way of describing this, rather than saying you do not have commit rights to the repository, well, that's certainly true. Effectively, what it means is that you cannot push content to that repository.
Right. That's right. That's right.
That's super. That's a good point. What you can do is you push content to your own fork or your remote copy of the TC repository, and then from your fork or remote copy of the repository, you send a pull request to the TC repository. That's
right. And this slide is as much about introducing these conventional terms, origin and upstream, as the names of the remotes that you use. So the reason that's important is because you're gonna hear a lot of people talk about origin and upstream, and you're gonna see that like in tutorials and probably in Chris and Robert's workflow as well. But again, those are just conventional names. All right, so I have a little picture of that. So again, we have our master or our main project repository out there on GitHub. You're going to fork it to your own copy of that out on GitHub. So you can see that one's under my name, Dr. Macro. And then I'm going to clone that to create my local repository. And so now my local repository has my origin remote, which is just like it was before in the previous picture. That's the one I'm going to push to and pull from. And then we have our upstream remote, and I'm only ever going to pull from that. So I can, if somebody makes a change to the main project repository, I can pull that into my local one, and then I can push those changes up to my fork and keep all three of these in sync. And then at some point you create what's called a pull request, and I'm not going to talk about that in any detail. But I know Chris and Robert will get into that in more detail. All right, so another important Git concept that's different from a lot of version control systems is a two-phase commit. So files are committed in two phases. In the first phase, you do what's called staging your files for commit, and the command there is add. So you say git add, that adds all the files that Git knows about that you've changed, or if you created new files and you say add my new files, you can add those as well. But they haven't been committed yet. They're just waiting to be committed. And then you take a separate action to actually commit the files that have been added. And the reason that that's important, and the reason Git does this, is it lets you precisely control which files are committed and when, right? So for example, to go back to Tom, Tom's been working on 18 different topics over the course of the last 2 hours, and he's made 50 different changes, right? But he doesn't want to commit all 50 of those changes as a single action because those changes don't all relate to each other. So he can go through and say, oh, well, these 5 topics, I changed these all to reflect this new, a new feature that was added to our product. So I'm just going to select these 5 topics, add them, commit them with a single commit message, documented new feature X, right? And then go to the next set of topics that were related to each other. So you can, by using this git, by using the add and then commit, you can carefully organize the sets of changes that you commit together with appropriate commit messages. And that's really important. But this is where the discipline comes in that Chris was talking about, because you do have to think about this if you're doing it, if you're working in that way that I just described, where you just, you're doing a whole bunch of stuff and it's not all related, but you're just doing it. Then you come back after the fact and you go through and carefully commit the things, commit things that are related together as separate commits. So that does require some discipline. You have to think about your commit messages. You have to think about, are these changes that I want to commit together or not? But once you get used to that, it should become second nature. And it might also, affect the way you go about doing your work sometimes. That you organize your work in a way that makes the commits easier, rather than having your work be more chaotic, if you're a chaotic work person like I am. All right, so the best practice there is, you want to commit related sets of changes together. That makes it easier to track the change history, and it also makes it easier to undo things, right? If you have a single commit that reflects completely unrelated changes to 2 different sets of files, and you realize you need to undo one of those sets of changes, but not the other one, there's no way to do that easily with Git. You actually have to undo all the changes, and then go through a big hassle to break those, basically break the commit apart. So yeah, don't do that. This also makes it clear that it's better to commit small sets of changes more often, rather than doing bulk commits of a whole lot of work. All right, pushing and pulling, we talked about this a little bit, but when you push, so you're sending commits that are on a branch to the remote repository, or to a remote repository, whichever one you choose to push to. And when you pull, you're getting commits on a branch from a remote repository. And so by that mechanism, you're syncing up the history of 2 repositories. We talked about branches a little bit, just to emphasize they're lightweight, which means they're quick and easy to create and quick and easy to delete. And so you can use branches to isolate your work and avoid merge problems, right? So one of the things that whenever you're collaborating in any environment is you want to avoid a problem where 2 people have made conflicting changes to the same file and tried to commit them or have committed them at the same time, right? So by using branches to isolate your work and by using good communication among your team, you can better avoid merge problems.
So what happens?
Yes.
So this is Maria with another question. So what happens in that situation where you have different people making changes to the same branch or the same content? Like how, so, and what happens when you try and merge them? Like how do you know there's a merge problem?
Because Git will tell you, right? So for example, let's say you and I are both working, we've both made changes to the same topic. I commit my change first and push it up to the remote repository. You've then started to make, you've made changes, and you go to commit, you commit your changes locally and you go to push them up to the shared repository. Git's going to prevent you from doing the push because it's going to say you're now behind what you're trying to push to, which means you need to then pull the latest version into your branch. Well, if as a result of that pull, it's pulling a change to a file that you've also changed, right? Git will do a diff and it can tell whether there's a conflict, whether, the same basically the same line in the file was changed in two different ways. It says there's a merge conflict. And then you get to decide how to do that. I think I actually have a slide on that a little bit farther on, but basically Git can detect conflicts, right? And then it's up to the humans involved to figure out how to resolve the issue.
I think that's probably not how most of us would encounter this problem. You're not going to be prevented from pushing your changes up. I think because we're working on our own forks and then trying to merge into the main thing, what's more likely to happen will be that Elliot sends changes into the main TC, and one of the administrators says, yep, that's good. It goes into DITA 2.0. And then Maria, you've made changes. You push those up to your local, or it's your copy of the repository. It's when you go to suggest the change, to make the pull request and say, hey, put changes into DITA 2.0. GitHub itself will tell you, you can go ahead and suggest this, but somebody's going to have to resolve the conflicts because you've made changes to the same file and Git doesn't know which one to use. And at that point, either you have to fix it or the TC administrators can figure out a way to do it. But yeah, and that's how it's more likely to happen.
Sorry, this is Scott. Do you find that source tree is the easiest way to handle the merge conflicts? Or is there a different, I guess, conflict resolution tool?
Let me get to my slide on merging actually, because I think we can more clearly
Can I also just jump in for Maria's purpose and say, I think that given how we are going to be working on different repositories, and if we kind of try to have people working on different chunks and different, like groups of topics, we're not likely to see a whole lot of merge conflicts. Robert, I don't think you and I have seen any really so far in our work together on the main spec content. I'm not saying it won't happen. I think there is potential for that to happen, particularly with some conref files. But I don't think it's going to be a huge problem.
That's right, especially in the way that we're working, within this team. You're correct. It's probably not going to happen. And just being disciplined goes a long way to avoiding conflict. It's much more likely in the context of an open source project where coordination is really minimal. Yeah, so maybe we don't need to spend, I'm mindful of the time here. I don't want to take up all the time, and I've already done that to some degree. Cherry picking, I'm not going to talk about any of this. I do have a slide about pull request.
There we go.
What's that?
I was just going to say, yeah, I probably don't want to get into cherry picking and rebasing in this call.
Right. Yes. We'll just. You guys can go look that up as you can. So pull requests. So this is the workflow that we've been talking about, where you've created a fork of a repository. You then clone it locally, you make changes, you push back up to your fork, and now you want to communicate those changes to the people responsible for the main repository so they can pull them in. And that's called a pull request. And GitHub and other systems like Bitbucket make it really easy to create a pull request. Basically, whenever you push anything up to your fork on GitHub, when you go there, it'll say, hey, you just pushed new, and I can make a pull request for you. And it knows that you're associated, that you forked from, the main, the main project repository, and you just push a button and it'll create that pull request, and then it'll show up in the inbox of the people like Robert and Chris, who are responsible for actually doing for actually merging in those changes. And so that's the main project. What do I want to say? The main workflow there. One of the nice things about pull requests is that it's not a one-time thing. You can make a pull request, and then let's say Chris says, oh no, this language you haven't used should correctly, so go back and fix it. You can go back and fix it. You can push new commits to your pull request branch, and then those will automatically get communicated then to the the repository that you've requested, that you sent a pull request to. So you can have some communication and revision through the pull request itself as a way of working through the act of contributing those changes.
When you say something like this, I'm envisioning that a tool like SourceTree would have some sort of page where you that lists the pull requests you've made up until such point as the owners of that repository have done that pull, and then the items on your local list show that they've now been pulled, so that that's been done.
GitHub certainly does that for you. So if you go to the GitHub page for your repository, it'll show you your open pull requests. I don't know if SourceTree does that. I haven't actually bothered to look.
I wouldn't think so, because I think, yeah.
Sorry. I was just going to say, Tom, no, SourceTree won't do that for you. Inevitably, when you're working with Git, you both are working with like your local environment on your hard drive. SourceTree is great for that. And then you will also be spending time going to the web page for your fork of the DITA TC repository.
Yeah, that makes good enough sense.
So Tom, if it's okay, and you could let me share the screen, I can actually run through a demo of all of this.
I made you presenter.
And I'll just add, I also have a slide deck that is more of a cheat sheet for, here's a numbered list of, the steps you would do in SourceTree if you're doing, work that you're going to want to contribute to a repository. So we can, after Robert does his demo, we can walk through that slide deck too.
So
it's more simplistic.
Yeah, so this demo is not going to use SourceTree because I don't use that. I use the command line, but this should sort of just reinforce the workflow and show you what's happening using the terms that have just been introduced by Elliot. So hopefully you should see my browser now, and I'm currently showing the main repository for the specification. This is the Oasis repository. So when you're working on this, the first thing you want to do is fork, which I've already done, so I won't click on this now. But that's going to create your own fork of the repository under your own user ID. And I've got it over here. It looks very much the same. The only real way to tell the difference is this little bit right here, and the URL has my own user ID instead of the Oasis ID. I've now got my own fork on GitHub. Of course, I work with this a lot, so I've already got a clone on my hard drive. So this is the shell terminal for working with Git. I've got all of my repositories that are my own forks in a GitHub directory under my own ID. So this is GitHub Robbie under DITA. This is my own fork of the repository, and I'm on the master branch, which is way out of date. It's the errata stuff. It's not DITA 2.0. So in terms of storing repositories and remotes, you can see here one of the commands I've done is just show what remotes are connected. Origin, we've used that word a lot. That is my own repository. Upstream is the Oasis one. So first thing I want to do is fetch upstream to make sure I know everything that's upstream. So my repository is fully up to date. If it wasn't, you would have seen a whole bunch of downloads really fast right there. But that means that my clone here on the hard drive, my Git installation, now knows everything about what's happened in the main Oasis repository. And so now I come in and I want to create a new branch where I'm going to do some work. And so
Robert, a question there. Maybe I should already know this from what Elliot said. You explicitly said fetch upstream. That's a pull, right, from upstream.
yeah,
Are the forks, is your on GitHub, are your forks automatically synchronized with the repositories that they're forked from, or is that something that you also have to do yourself?
No. Once you've created the fork, everything sits there unchanged until you make a change or push a change. So fetch and pull are two slightly different operations. I like to use fetch. It just means go out and find out everything and store all of that data, but don't actually try to make any changes and don't bring anything up to date. It just means that I know everything that's going on. Pull is generally the same if you're pulling from upstream in most cases, at least for our purposes. So to check out a new branch, check out -b. I'm going to call this branch live demo, which probably means something's going to break. And I'm going to base that on
Robert,
upstream.
can I interrupt? Oh, sorry. You're probably getting the key thing, that this is, you're going to get a copy and create your branch first. You're creating your branch based on the DITA 2.0 branch and not the DITA master branch or the errata branch.
Yes. So when I'm checking out the branch, I'm doing two things. I'm giving the new branch a name, live demo, and I'm setting this code from DITA 2.0, the latest spec code.
Your audio went
So
out there.
I'll do that.
Robert, and we didn't quite hear what you said about the upstream / DITA 2.0.
Okay, so I've given it a name for the branch and a starting point. So my name is live demo, and the starting point is the latest DITA 2.0 specification, that branch. So I hit enter, and you can see I've set up a live demo branch. It tracks that 2.0 from upstream, and it has switched to the branch. So now, if I go into my directory over here, Rob under DITA specification, this is all set up now to match that branch. This is all the latest DITA 2.0 stuff. So obviously, first thing I'm going to do is go and make a change here. Let's see, I think in the directional at, I want to add, I'm going to change the URL on this link. Oh, I can't do that because this thing's hiding. There we go. I'm going to change it from the actual useful page to example.com. And let's see, I want to be destructive. So I'm going to make one other change. Call it GITA because we are doing a Git demo here. So I've just changed two files, ridiculous, trivial little changes. I'm going to go back to Git, and it tells me those are the two changes that have changed. If you're in source tree, those are going to be shown as untracked changes. So I'm going to add both of those independently. So now I've added them, but I haven't committed anything. So next I want to make a commit. I'm going to add a message.
Robert, before you do the commit,
Yes.
I was going to suggest
Yep.
you do git status just to show
Oh, yeah. Okay.
results of adding.
Well, so I'm going to now git push. So I did 3 things there in sequence. I added all of the changes, all the files I wanted to change. So I associated the message with it. So this is, sorry, this is over the announcement here. So yeah, so here I made and then I've pushed it up. And so already, if you go to GitHub, see it says right there, I pushed up live demo less than a minute ago. And so my changes are live on the web, but they're only in my fork. I haven't done anything to the main repository with these ridiculous changes. Now, say I want to try to trick Chris into accepting these changes into the specification. I click on the open a pull request thing, and I have to select where I want it to go. I want it to go into DITA 2.0, and it's coming from live demo. And here's where I would give a title to my pull request. I would describe them, hopefully better than this. And then if you scroll down, you can actually see the changes here in the diff, where you can see that I changed the URL from that w3.org useful one over to example.com. And my other one didn't show up. Well, there we go, live demo. Oh, I didn't save the file. Yeah. So anyway, that's sort of the workflow process. It's pretty quick. It's pretty easy. The nice thing here is that I've created my live demo branch, and I've pushed it to my own fork. And by doing this pull requests, I can easily see what I've changed and suggest the changes go in there. But if I look at that and say, oh, I didn't want that. I don't want it at all. It's a pull request. And I mean, there's nothing that says anybody on the TC ever has to see this work until I feel it's ready to share. And if you go to, sorry, I did that rather quickly, I bet. If you're looking at your own fork out on GitHub, there's a thing for commits, a link for commits, a link for branches. I'm going to click on branches. And this shows all the branches that I have pushed up and whether or not they're accepted. These are the branches that I've pushed up. I have not suggested all of them to the TC. Some of them were just test work. This one, for example, is just test work. This one was the changes I made as a result of the August meeting that Chris and Tom and I had. This is when I changed a bunch of keys. So these are all branches. They're all totally independent. And whether or not I choose to make this change suggestion to the TC, I can now go back here and say, I can create a new branch, totally new branch. And so that won't have the changes I just made in it. If you open these files, you'll see they've just been backed up. They've just reverted to where they were because they're now back at the specification level. It's not refreshing as quickly, but yeah, there we go. You see my change to example.com. Now I can make more changes. I can do something totally independent. I'm going to say, go into this direction thing. Okay, so I'm going to say that, and I'm going to make one other change just in case we have time to show it. I'm going to actually break the XML. I removed the start tag there. So now, status. Oh, you can see there are some changed files. So the thing I've added there is in red. The thing I haven't added, that's why I didn't add the right file earlier. The thing I haven't added to this commit is there. I'll go ahead and add that one too. So now you can see I've got 2 files that have been added to the commit I'm currently working on. Oh, I didn't make the commit yet. So I tried to push without making the commit, nothing happened. So you see, it's really hard to actually break things, because it's a lot easier to not push changes that you want to go up there. But regardless, I just pushed up my oops branch. If I reload my branches, you can see that oops was pushed up.
So Robert, do you need to then delete your live demo one if you know that that one's bad, or you just keep it for posterity's sake? Or
it is totally up to you. There is no need to delete it. You can end up with 5,000 branches, only 10 of which have been merged into the main TC work. For my own sanity, once this is done, yes, I will delete live demo because I don't want that hanging around. Once my August work from the spec is merged in, I'll probably delete that one as well. But yeah, these are all totally independent of each other. So the fact that I have live demo there doesn't change anything that I'm working on anywhere else. I think that's one of the big differences conceptually from SVN. That's where the branching model really shines, because I can do that work under live demo, pretend that was good work, pretend I was doing something useful there, but it's not complete yet. I've committed the changes I have, I've pushed them up, they're stored, anybody can look at them or comment on them if they want to. But I can also start over on something unrelated in a different part of the specification and do that work and push it up. And they're not tied together. Like you don't have to do them in order. Whereas with SVN, I would do the work, but then it's basically, I have to put it back into the main repository and add it in there before I work on anything else, or else I'll get totally lost. Here I can do things independently, and that's where the good hygiene comes in. The stuff that's related to live demo should be done while I've got live demo checked out. The stuff that's oops should be done while I've got oops checked. But yeah, for hygiene purposes, you can delete them when you're done. It's not necessary.
what happens if you're working on the same files, right, that are part of live demo and part of oops? It just depends on where you send that particular commit to where those will be saved.
Yeah, well, and again, this comes into hygiene, because if I'm doing work on the same file in 2 different branches, I'm going to run into trouble. I'm causing merge conflicts for myself, and I mean that's as powerful and as smart as Git is. If I tell it I've made this change to this file, and then I've told it I've made this change to the same file, figure it out. It doesn't know which change is correct. Both of them, neither. Maybe something needs to be merged together. So you should not make branches where you're doing different work on the same file. When you have separate branches and you're doing different work in parallel, it should really be on different things. Like you might have a branch where you're working on the specification and a branch where you do that safely. Or you could have a branch where you're working on language spec stuff and a branch where you're working on architectural spec stuff, because you're not make your own conflicts there. But if you want to do 2 separate things to the same file, then you are going to have to wait. You need to make the branch, push it up, wait for it to go into the spec, and then continue from there.
Okay, yeah, I was thinking more from like a product perspective, where you might have the same map file and a lot of the same topics, but you've got version 1.2 for one product, and then you want a different branch for 1.3, but you're still kind of working on maybe both branches simultaneously, and how that would work.
Yeah, it's not really something we're going to get into, so I'd rather not confuse people.
Yeah, I would, Scott, the sort of branches you do in product documentation work in the CCMS. This is different from branches here in GitHub.
Yeah. So if I can, I'd like to show one more thing here. You may have noticed that a little red X appeared next to this one, whereas this one had a green check mark. And you'll recall that I removed part of an in tag. I actually broke the XML, so I pushed up bad XML. What's really pretty nifty about this with the way we've set up GitHub is that whenever I push my changes up, it automatically runs this tool called Travis CI, Continuous Integration Tool. It's grabbing a simple set of document types and building them against all of whatever is in your fork or whatever in your branch for grammar files, and that's also building the specification from your branch. So in this case, I broke the XML. So when it tried to build that to HTML, it failed. It got a build failure because one of the files was invalid. It couldn't parse. That build failure broke the build. And so just looking at my branches on GitHub, I can see that little red X that says something is actually broken here. That makes it a lot harder for us as TC contributors, for me and Chris as administrators. It makes it a lot harder to introduce something that breaks our spec, which is wonderful. I'm so happy about that. It means if we try to make grammar files and we put in, a typo in the DTD, we're not going to check it in and go on just blindly not until someone tries to test them. It's all being automatically tested. It means if you put in a broken conref and suggest a broken conref, you're going to get this little red X, and you'll be able to fix it before you actually make your pull request. So, for my part, as in the contributor role, it saves me break a conref. I know about it before I tell the rest of the TC I want to change this. Whereas back in SVN, break that conref and check it in, and I wouldn't know until somebody tried to build the spec later that things are broken. So that's just another nifty aspect of this.
And I'm just going to add that GitHub doesn't do that automatically. This is simply, Robert set this up for our main DITA TC spec repository, and it's lovely.
Yeah, and so to get this automatic building in your fork, there are a couple of steps you need to go through. It's basically just telling GitHub that Travis can look at your account, and then telling Travis to work with this fork. But it's something that, we use it over in the DITA Open Toolkit as well. That's where I learned about it. And it's set up for the DITA TC itself so that even if you don't want to do this, even if you don't want to have these builds running with your own branches, whenever you create a pull request, this also automatically runs on the pull request. So the pull request itself will say whether or not the thing passed.
For the main, the main spec. It's not set up for lightweight DITA or learning and training or TechCom.
Yep. And so here's an example of an actual pull request, and this is just one that I opened a week ago with refactored topics based on a live call with Tom and Chris, where we went through a bunch of the elements to try to figure out what needed changing. And you can see I've got 2 commits that are here as part of this. A little easier to see here. The first commit was to refactor the data element and to add examples. The second commit was to rewrite example sections for a bunch of different elements. And you can look at the changes independently, or you can look at the entire changes. Over here, I'm looking at everything that's changed in this commit. Things that I've deleted are in red, things that I've added are in green. So lots of changes to examples. But this is what a pull request looks like once it's open. And again, you can see from the little green check mark here on the last commit that this has passed a Travis build, so it's safe to check.
Have we lost Robert?
Robert, are you still there?
I don't see any audio on his thing. I think he might have dropped off the audio. He's still connected to the WebEx though. Maybe Chris, just until he comes back, should I switch and let you show your slides about
Sure.
source
Sure. I'm
tree?
just looking at time. We've got a little more than 15 minutes. I have both, yeah, Tom, please switch me as presenter.
Okay. Done.
All right, guys, can everybody see my screen?
Yeah, we see it. Well, I do.
Okay. I figured we all needed to have a good cheat sheet. So this was my attempt to put together my cheat sheet of how to do things with GitHub and SourceTree and DITA TC repositories. And it was kind of a useful experiment because it actually forced Robert and Elliot and I to talk quite a lot about what our different workflow habits were. So in this slide deck, there's really sort of 3 sets of content. One is how to get set up, which would be actually forking it into TC repository, cloning the fork to your local system, adding the upstream repository, and then fetching content from the upstream repository. That's all the sort of initial work you would need to do to, once you've installed SourceTree, to get going. And then under item 3, it's what you would actually have to do, the steps if you're going to do work in one of the repositories. And then number 4 is best practices. I think Robert has rejoined. Have you, Robert?
Yes, I have.
Okay.
I'm not sure why my phone disconnected, but I just kept right on talking.
Okay. Should we go back, Robert, to what you were demoing, or do a quick tell?
What was the last thing you saw of what I was demoing?
Your pull request, I think.
Yeah, I think that's really it. That's a pull request that has a couple of different commits and is waiting to be accepted, and so that's where your work as a contributor will generally end until one of the editors comes back and says this looks great and merges it, and you're done. Or one of the editors comes back and says I think you should also make these changes, in which case you can add more commits, and it just keeps right on going.
All right, so let me see if I can walk through these slides and also maybe give you a look at my SourceTree, my local copy of SourceTree. But again, this is if you want to use SourceTree, install it. If you don't have a GitHub account, create one. And things are looks like this is a little out of sync sequence. I didn't really want workflow. This should be your setting up. So the very first thing, if you're getting set up to do work in a TC repository, is you actually have to fork it. And this means going to the GitHub repository page, click fork, and then make a note of your own URL. I'll provide a PDF of this set of spreadsheets, this slide deck, and in here you get the links to all the different TC repositories. So once you've forked it, the next step is cloning your own forked repository to your local system within SourceTree. And so this is the steps for doing it in SourceTree. And then once you've cloned it, you want to let SourceTree know, hey, this repository is really affiliated with the main DITA TC repository, which is, again, by convention called upstream. And this is the steps for doing this in SourceTree. Then the next thing you would do, and you saw Robert do this for the command line, is fetching from the upstream repository, which is bringing all the content, all the branches, the history, and making that available on your local system. So again, the thing to remember here is you have both your local working copy on your hard drives, you have your fork up on the web in GitHub, and then there is the upstream repository, which is like the main DITA repository that you're contributing to, whether that is the spec or TechCom or learning and training or style sheet or whatnot.
Chris?
Yes, Tom.
Am I correct that if you're going through these setup steps here, starting from the fork and then the clone, and then attaching the upstream repository, and then you do this fetch, if you're doing this all in sequence at the same time, in the space of a minute or two, then this fetch isn't actually going to do anything, because unless it just so happens that somebody is working in the main repository right at this very instant. Is that right?
Oh no, this is going to grab you all the content from the main repository and the history.
So the clone
and the information.
The clone doesn't do that?
Well, sort of. It's sort of, the clone gets you all of the information, but all it knows is that, and so you could, with great dexterity and use of hash codes, get to everything in the upstream repository, but don't do that. You need to add upstream so that it knows what's there, so that it knows upstream means this other place. This is what upstream is. And then, fetching from that, it's just a good idea. It's not going to actually transfer a lot of data to your hard drive, because all of what's in that upstream basically matches what you got in your own fork. So I think you're sort of right, but you definitely want to add upstream, and you definitely want to grab it so that that Git install on your system knows everything that's associated with upstream.
Okay.
Yeah, I was really trying to put together just, when I started working with Git a couple years ago, I found it a little too complicated for me to do without having what I thought of as a cheat sheet of here are the steps to do whenever I'm doing work. And so for the benefit of people trying to get set up with it, I figured, if you're going to use SourceTree, it'd be helpful to know here's what to do to get set up.
And another important reason to have this in the setup is that, I think we've mentioned on previous calls, that if you do manage to really mess up your local Git system, you just delete the directory and create a new clone. And in that case, you absolutely will need to fetch, because you're definitely going to be out of date. So in terms of normal practice for setting up, it's good to do this.
And I have thrown away my entire working directory and started all over from scratch. Hopefully you won't have to do that, but if you do, you're really, it's not a big deal. You're not really going to lose anything, and you just follow these steps and get started again. So here is my cheat sheet for what I think people who are working, or contributing to different TC repositories should do. And I think this is appropriate whether you're using SourceTree or the command line. But the very first thing you do if you're wanting to set out and, I'm Maria and I'm going to edit the, whatever particular map of topics for the TechCom stack, is I would go ahead and I'd create a new branch, and based on the appropriate branch, the upstream repository. And if by appropriate branch, you never want to work on master, and each probably, little TC repository might have its own conventions. For the main spec work, for example, Robert and I, we're working on either a DITA 1.3 errata 02 branch or a DITA 2.0 branch. The first thing you do if you're wanting to get started for doing some work is you create a new branch. This is your own personal local branch that is based on a branch of the upstream repository. You do your work locally, you commit your changes, and then you push your changes to your fork. And then from your fork, you open a pull request against the upstream repository and say, hey, I want to contribute this. And it's pretty straightforward and easy to do this in SourceTree. And here is a cheat sheet for how you would actually do this in the GUI, which is basically saying, hey, I want to check out the upstream. In this case, you can see in the screenshot, I'm saying, I want to check out upstream DITA 2.0, and I want to make the local branch. I'm going to call it, in this case, I called it my spiffy new branch. And I'm saying, yes, I want this to track the remote branch. And I kind of went along and I did a bunch of work, and SourceTree will let you know that you've got uncommitted changes. And you know, it has a little GUI here. We can do more of a demo of it today or in another, call if we have time, in another call. And it'll say, hey, these are the files you've changed. What do you want to do with them? And you can stage them, and then you can commit them. And we'll try to get to some of the best practices for committing. But you can basically, you give a commit message, you push commit, you press commit.
Is that,
and
Chris, is that that's the two phases of a commit that Elliot mentioned in his slides, right? Staging and the committing?
Yes. Staging, committing. And then there is also the, pushing it to your branch, which is saying, hey, I've got, I have this commit. It lives in my local working directory of Git. I want to push it to my fork.
And as a shortcut, there is a little checkbox on that commit window where you can commit and push at the same time, if you're confident.
If you want to do that, or if you feel like you're not, you don't have too many different remote branches, then it might get confused, or you might get confused about it. Then it's a pretty straightforward thing of you go to your, from a web browser, you go to your fork, and to be honest, I have to bookmark, what are my different GitHub forks? Otherwise it's a pain to figure them out. So I go to my fork, and the important thing here is whenever you're opening a pull request, the first time if you just go to your fork in a browser, it will probably by default be on the master branch. And you're never going to want to open a pull request against the master branch. So the first thing you do is change to whatever is the appropriate branch, whether it is, Errata 02 or DITA 2.0, and, switch to the branch, see your commit, and click New Pull Request. And then you've got a GUI screen, and Robert was showing this, where you can provide the necessary information. And the nice thing to know is once you also can, once you've created a pull request, you can continue to make commits to that pull request until the TC administrator has merged it. So if you're doing some work and you want to get some early feedback on what you're doing, you could go ahead and open a pull request with 1 or 2 files and say, hey, please review them. Am I going in the right direction? So something you want to add anything about, Robert?
No, that's right.
Okay. And then I know we're really close to time here, but just some quick, we put together some kind of best practices for commit messages, pull request messages. And, for example, Robert talked about it, is you don't want to make a commit that involves unrelated changes to a whole mess of files. It's much better to do a commit for example, you have updated, all of the topics for the UI domain to use the new element reference template. So we've got some examples of, what are good or bad commits. And the same thing, for commit messages. Short, clear, and, so that somebody reading the commit message who also knows about our spec and the TC work could know what has changed. And if you go and look at the commit log for like the spec repository, you're going to see I've made a whole lot of not good commit messages as I've gotten up and running with it. And a similar kind of, best practices for pull requests. But I am thinking we are, 2 minutes before the end of our time. So I want to leave some room for questions and ask whether people think that we need to do another kind of Q&A or maybe an opportunity for people to ask questions after they've tried getting up and running with their tool of choice, whether it's SourceTree or the GitHub command line.
Well, this is Maria. I would, I guess it would be nice to be able to watch someone actually do this and follow along, or have some, just have some help in getting, creating the fork that we need and make sure we're doing all that early stuff correctly.
If that's something that's of value to people, I would be willing to be a guinea pig, being basically just as new, almost just as new to SourceTree as anyone who hasn't installed it yet. Really, essentially the only thing I've done is install it and go through Chris's configuration steps. I have not done any commits or pull requests to my local. I've not done any commits to my local repository or obviously anything further of pushing commits or doing a pull request. So I would be willing to do another session. Glad to do another session where I would be the clueless guinea pig walking through these things for the first time and showing, helping other people understand what we do all together, if that's of interest.
And Maria, if you want to have a demo from the very beginning, I maybe you'd be willing to be a guinea pig, like starting with actually getting a GitHub user ID and forking a repository.
Yes, that would be great. So I've already downloaded SourceTree, but that's like about as far as I've gotten. And I already have Git. And I don't remember, because I don't remember what we used. Remember, I did some reviewing of the 1.3, or maybe it was Murata. And do you remember that? Anyway, I did some work with Deb. Deb and I kind of split up some work, and I don't even remember what we worked in back then. Yeah,
I don't think it was GitHub.
Yeah.
Yeah, that probably would have been Subversion.
Well, so sounds like we can do at least one. We can do another session, and we can start with just doing a walkthrough of the getting set up, and then all these basic steps in SourceTree. Are there folks that would want the same for the command line?
I would love any demo or training or watching I could do would be helpful at this point.
Okay. Well, why don't we try to get that scheduled? Maybe we'll ping people about it at next Tuesday's TC meeting and move on forward. In the meantime, I can make a PDF of the slide deck and send it out for folks who are interested.
And after
That would be
finished,
great.
after this is finished, I'll make the recording of this WebEx, GoToMeeting available online somehow as well.
All right. Well, Tom, many thanks for setting this up, and everybody thanks for being interested in calling in.
Thanks to the three of you for presenting too.
Yeah, thank you.
Yes, thanks very much, guys.
Thanks, everybody.
Bye.